In the first section, we solved systems of equations by the geometric method, or graphing. In this section, we're going to look at an algebraic approach. Let's look at our first system. We're going to solve this system here, 5x plus 3y equals 19, and 2x minus y equals 12. Remember, to solve a system, what we're looking for is an ordered pair that satisfies both these equations at the same time. Now, in this section, we're going to look at what's called the substitution method. And what that means is we're going to look at both of our equations and we're going to determine which one of these equations would it be easier to take and solve for a particular variable, either x or y. When I look at the second equation, I see that I have 2x minus y equals 12. It would probably be pretty easy to solve the second equation for y. Let's write it down. 2x minus y is equal to 12. How do we solve that for y? Well, we can simply subtract 2x from both sides of the equation. Minus y is equal to negative 2x plus 12. Notice I just chose to write the negative 2x in front of the 12. It could actually be written in any fashion, either 12 minus 2x or minus 2x plus 12. It doesn't really matter. Now to solve this equation for y, I see since I have negative y here, the last step is to multiply both sides of my equation by negative 1. Multiplying the left-hand side by negative 1, I get positive y equals, multiplying both these terms by negative 1 gives me 2x minus 12. So what did I do to solve for y here? I multiplied both sides of the equation by negative 1. Now that I did that, notice I have y equals 2x minus 12. I've solved my second equation for y. Now I'm ready to incorporate what's called the substitution method. Since I know that y is equal to 2x minus 12, I can take this expression here. Now remember, this equation was taken from the second equation, so what I'm going to do now is take this expression and substitute it in to the first equation for y. In other words, I'm going to take this expression, go up to that top equation, and in place of y, I'm going to write the expression 2x minus 12. Now you may be asking yourself, why are you doing that? Well, what's going to happen once I make this substitution in for y, this first equation will be in terms of x only. Since I only have one variable x, I'll be able to solve for x. So let's continue. Now I'm going to take my top equation, 5x plus 3. Now here we go. In place of y, we're going to put in this 2x minus 12. So 3 parentheses 2x minus 12, that's equal to, here's my 5x plus 3y equals 19. Now my job is just to solve this simple linear equation for x. So here we go. 5x plus, do you recognize the distributive property here? This gives me 6x minus 3 times negative 12 is negative 36. That's all equal to 19. On the left-hand side, now what I'm going to do is collect like terms. 5x plus 6x, 11x, minus 36 is equal to 19. Now I'm going to add 36 to both sides of my equation. 11x is equal to, when I add 36 to the left-hand side, negative 36 plus positive 36 is 0. And when I add 36 on this side, I'm going to get 55. And notice that's positive 55 because I add positive 36 to both sides of my equation. Now finally, I'm at the point where I have 11x equals 55. I'm sure you can easily see that the last step here is to divide both sides of the equation by 11. Dividing the left-hand side by 11 simply gives me x. Dividing 55 by 11 gives me x is equal to 5. Now, big caution here. Don't stop and say x is equal to 5. Think about what we're doing. We're solving a system of equations. Not only do we have to find the value for x, but we must also find the value for y. We're looking for an ordered pair. So don't stop here. The way we solve for y is we can actually go back to this equation here, where we have y is equal to 2x minus 12. To solve for y then, we're going to take the value we found for x, 5, and substitute this right back into that equation. When we do, we can see we'll have, we can write this right below. Let's write it right below the x here. Y is equal to 2 times x, but x is 5. 2 times 5 is 10 minus 12. Let's do that one more time so you follow carefully. X is equal to 5. Since x is equal to 5, we need to find the value of y. We go back up to this equation that's solved for y. Since we have x equals 5, we take that value, substitute it into the equation for x. That gives me y equals 2 times x, but x is 5, which gives me a product of 10 minus 12. And there we have it. So y is equal to 10 minus 12, or y is equal to negative 2. So what does that mean? That means if I were to graph these two, or they cross each other at the ordered pair 5, negative 2. 5, negative 2, these two values for x and y will make this top equation true as well as the bottom. It is the intersection. Now remember that when a system of equations has a solution like this, an ordered pair, we call the system consistent. So we'll say 5, negative 2, and we'll just write the word consistent. And all that means, remember, is that yes, indeed, this system does have a solution. Not too bad, was it? Let's try another one of these. Let's look at the following system. And again, we're going to incorporate this method we're calling substitution. But this time, we're going to add just one more piece of fun. We're going to this time put some fractions into our original system and see how we can deal with it. So we've got here x over 3 minus y over 2 equals 1. And the second equation, x plus 4y is equal to 8. Well, right away you're saying to yourself, I hate fractions. Most students do. So if you hate fractions, we know methods of how to get rid of fractions in equations. If you'll remember, to get rid of fractions in an equation, we can clear the fraction by multiplying through by the least common denominator. So in this first equation where we have 3 and 2 as denominators, it's pretty easy to see that our least common denominator is 6. We're going to multiply everything in this top equation by 6. Oops, wrong side there. When we do, the first equation becomes 3, and then 6 goes twice, so I'll get 2x. 2 goes into 6 3 times, minus 3y equals 1 times 6, and I get 6 there. I'm sure you would agree that working with these two equations is a lot better than working with the original two, because in those original two equations we had fractions, which most people don't really like working with. So now again, we're going to incorporate what we call the substitution method for solving the system. Again, analyze your two equations. Determine which one of these equations will it be easier for you to solve for a single variable, either x or y. It makes no difference. Well, I think you would agree by looking at this top equation, it's going to be fairly simple to solve for x. In fact, all I have to do to solve for x in the second equation is to subtract 4y from each side. So when I do, let's just write it to the right of this, I'm going to get x equals subtracting 4y from both sides of this equation gives me negative 8 minus 4y. So there we have it. Now what are we going to do next with this expression? Since this top equation yielded x equals negative 8 minus 4y, we're going to take this expression for x and substitute it in to the second equation. Negative 8 minus 4y is going to go right in to our second equation for x. What that's going to do is create the second equation in terms of y only. Then we're going to solve the equation for y, go back and find the value for x, and then we'll be done. So making the substitution gives me 2, and in place of x, I'm putting negative 8 minus 4y. Following along this equation here, minus 3y is equal to 6. Do you recognize the distributive property here? That gives me negative 16 minus 8y minus 3y is equal to 6. Now all we have to do here is collect like terms. Negative 16, negative 8y, and negative 3y gives us negative 11y, and that's all equal to 6. Finally, what we need to do here is add 16 to both sides of our equation. When we do, we get 11y is equal to, adding 16 to both sides gives me 22, because I have 16 plus positive 6. And finally, we're going to divide both sides by negative 11 to give me y is equal to, now don't forget, 22 divided by negative 11 gives me a negative 2. So that's our value for y. Again, don't get too excited and make the mistake of saying, I'm done, y is equal to negative 2, because you're almost done. We still need to find what the value of x is. So to find the value of x, we take the found value of y, substitute it into this equation, which will give us the value for x. So using this top equation, we have x equals negative 8. We just found the fact that y is equal to negative 2. We'll substitute it up here in this equation to get minus 4 times negative 2, which gives me positive 8. So x is equal to negative 8 plus positive 8, so x is equal to 0. Now what's my final solution then? It's not just y equals negative 2, nor is it just x equals 0. What it is the ordered pair 0, negative 2. What does this mean again? It means if I were to graph both of these equations on the same set of axes, what I would find is the two lines would cross at the ordered pair 0, negative 2. Again, since we do have a solution, we consider the system to be consistent. Remember, consistent just means that there is at least one solution.